Okay, so the recording starts. So, good evening, gentlemen. Okay, the attendance later we sign. We'll let you settle down first. So, again, just quickly introduce myself. My name is Dr Alex See. Okay, I'm a lecturer, so I'm working with Mr. Chan on this module. My only fear is that sometimes if I use a lot of projector, right, sometimes the image very sharp, very bright. When you record the video, it's very glaring. So we try first. But I tend to like to teach using the whiteboard. Explain using the whiteboard. So we see how first. Later we will go on. But let me just quickly touch on where we are now. Okay, you all have the lesson plan, right? What we call. Okay, so can we take a look at your lesson plan? So now, okay, we are at where? You all know? Which week? I forgot to do my marker. Week 7, right? Yeah. So we are here. You can see week 7, 5th December that week. Today is the 5th, right? Topic 4. Actually, Mr. Chan, I heard he finished already, right? He said he finished. Topic 4. Okay, so we're going to move to topic 5. Oh, okay. So when is your common test? Do you all know? Next week. 2 more weeks. 2 more weeks. The week starting the 19th. On the 19th itself. On the 19th itself, because the dates that you see is actually the day on Fridays. You all see, right? You know, 19th is the Friday. December 19th is the Friday. So that day will be your common test. So your common test will cover topic 1 to 4. Okay? Any question? That means basically it's Mr. Chan's fault. Okay, so after that, then you have 2 weeks term break. But can I really encourage you for the common test? Please study because from historical data that we see, students who fail common test, high chance they will fail the exam. Really, this is from history what we see. Okay, so please study for the common test. Because 20% quite a lot. Because students like who didn't make it for the common test, their marks being pulled down. That's the trouble. Okay, so please try to make some time to study for your common test and try to clear it. Topic 1 to 4. Okay, so then we will then move on to topic 5. So the common test will be we are confirm with you. Where is the venue? Is it here? Mr. Chan will say here. Okay, because they need to arrange the tables. But okay, let's follow. Okay, so if that's the case, any other things you want to question? So far, any concern or anything? Yeah. Common test, please come on. Please come on. If you don't have valid reason, then that's wrong. Okay, but then moving on, right? Let's say after common test, then coming back in January next year, then you have a lab test. Okay, the lab test is based on the lab 4. Okay, so that one is later part. Okay, that's for the lab test. Between 14 and 15. Okay, then we will start. Yeah, okay, and you have the lesson plan anyway. Okay, so gentlemen, so let's start. Topic 5. Yeah. So for my part, topic 5, right? So it's a mix of some theory and some calculations. Okay. So can you go to topic 5? Okay, can we take a look at here? Topic 5. Here, I'll bring the mouse. Okay, so basically, right, as you can see over here on topic 5, okay, we are looking at, in particular, things like sensors. Okay, now we will be looking at, are you familiar with op-amps? Operation amplifier. You may have some of you may have studied things like inverting amplifier, non-inverting, summing, those type of things. So that one will come later. Okay, so for this topic 5 mainly we are looking at things like sensors. Okay, and then for my part I also cover things like filters. Okay, so that one will be something that we will be looking at. Okay, so moving on, I think you probably know very well, you guys are from the industry, so you know that you work in the industry sector. I mean, industry, you all use a lot of sensors, I think, right now, be it in the military. Last time, I just share with you my background. Last time, I worked for MINDEF. I was with the, you all know DSO National Lab. You may have heard before. So basically, this lab is under the MINDEF umbrella. So we work for the under MINDEF for the defense side. DST? Not DST, DST sister, DSO National Lab, Defense Science Organization. So it's sister company to DSTA. DSTA is the funding, we are doing the research. Yeah, so for my part, we work with the Navy. We were doing those underwater weapons, so-called. You all know what torpedo? If you all may know, you all maybe watch some show. We were doing those torpedoes, and torpedoes like submarine, they launch those torpedoes. We do those countermeasures. Okay, so sensors, so we use a lot of sensors. So you can see over here, this is just a quick picture to show you the different type of operation from home appliance, right? Things like this kind of vacuum robot to military to very high-end stuff. Right? Okay, so now the very basic block for any measurement system is over here. The general block. What do you need? Okay, first thing you need a sensor. Alright, you need the sensing element. Okay, you need signal conditioning. Signal conditioning means what? Things like filtering, or you can do signal amplifier, right? Because maybe the signal very small. Okay, you need to amplify the signal, or it could be you are using those sensor transducer with current loop, 4 to 20 milliampere. Anybody familiar? Of you may have. Okay, so you might need to do some signal conditioning, right? Okay, now before the signal gets processed, okay, it goes to a data, maybe a data logger or something where you will have to digitize the signal. So you use things like analog to digital converter. So you convert the signal before you can capture all this data and log it, right? Okay, so this is a very general measurement block that you normally will see. Okay, now this one is a very common system. I think you all can probably guess what this is, right? Yeah, there's a solar. This is actually along Bukit Timah Road. Okay, so what happens is that now PUB now very consciously monitoring the water level of the drainage. This one, you know, opposite the market, one of the big drainage systems. So I think they got this company to install a lot of these. I see solar panel. There's a measurement system inside. So they're actually monitoring the water level in case of flood. Now, even to bring it to the next level, now they got camera. They mount those cameras overseeing the drain. Okay, so they have a control unit, control station, main control station somewhere. Okay, whereby they monitor all these things. So this one is actually an antenna. So you don't really see carefully. There's an antenna here. Yeah. Okay, so these are the very common system. Okay, now, so for us, right, for your course, what you need to learn is about something very basic. Introduction to sensor. What is data acquisition, right? You all have already started. You all haven't started Lab 4, right? Or you guys? No. You all started Lab 3, Okay, your Lab 3. Okay, Lab 3 you may have already used, right? You know the lab that you use. You all use the box, right? Okay, that one is a data acquisition, which is this fellow here. So it's a National Instruments hardware. Any of you use National Instruments hardware in your workplace? Never use. Okay, never mind. Okay, but basically what it does is an analog to digital converter. Okay, so for this before you use PC based system. Okay, so you can do this. Okay, so sensor, you acquire the signal before you can process to a computer. Alright. Do you know that now? I'm not sure if you know. Many of you drive also, right? You know now, LTA, traffic police now install a lot of those high-speed camera. Those are for real. You are involved in that. Those are real. Those real stuff now, CIE now got install those high speed. Because my brother-in-law works in Singtel, then he tell me they do LTA or project for them because they want VPN. You know what VPN? Virtual Private Network, secure network. So it's to secure all these cameras because the images is all Wi-Fi one, but the signal is secure one. Okay, now the reason why I share with you that because in order to capture all this image on any system that you use, you must use some kind of a high-end processor, right? Now, usually it's some industrial PC or some computer or something like that. Okay, so it's quite common. Okay, now so very quickly some definition. Now in your exam, right, there might be a couple of one or two definition questions. Okay, but I will try to guide you along in the exam. So basically, I think by now you should probably hear very well what is a sensor, right? Sensor is a device, right, that converts your analog signal into some electrical signal, right? Because otherwise you don't have electrical signal, how you want to measure the signal? Fair enough. Maybe I can be measuring temperature, right? Temperature, okay, or humidity. Again, so I think that one is a humidity sensor. That probably every room, right, they install something to measure the humidity of the room. Okay, so you convert that one into some electrical signal, right? Okay, so it's a sensor. Okay, now very quickly, okay, so but the transducer is a bit different. So if you ask me what's the difference between transducer and sensor, sensor is the simplest element. Basically what it does is that you convert the physical parameter, let's say temperature. Temperature is very easy, I use temperature as an example. Temperature, you convert it into voltage, right? Then you measure that voltage. Then you do some calibration. Okay, but for transducer, it's a little bit slightly one level higher because it may include some conversion for you. For example, if you use 4 to 20 milliamp current loop type of transducer, you know why you use current? Why use current? Why use 4 to 20 milliamp? Maybe some of you may have used, I'm not sure. 4 to 20 milliamp current loop. Why use current? Why don't you use voltage? Yes, very good. Because voltage, right? If you use voltage transducer, the problem is what? If you want to lay cable and you go for long distance, what happens? Yeah, voltage drop. Long distance, right? Your voltage will have voltage drop. Your signal will be distorted or weak. So if you use current loop, then you don't have this problem, right? Because current in the loop, no matter your wire can be quite long, can be talked about. Maybe, of course, you may put repeaters, but can go up to a few kilometers. No problem, because current. Okay, so a transducer has some conditioning here up front. So that means you have the sensor. This one maybe is your 4 to 20 milliamp. Okay, current booster. Okay, so you can boost the signal. Okay, so that's the difference between sensor and transducer. Okay, now another classification of sensor. Now sometimes we ask in exam some simple theory question. Okay, so for example, what's the difference between active and passive sensor? Okay, do you all know? Yeah, I think you can read from here, right? Basically, anything that is actively power supplied. Any sensor that is considered active, an active sensor, you need to put in external power supply, usually 24 volt, right? Industrial case, 24 volt supply to power up the sensor. Because if no power supply, the fellow cannot work. Okay, but there are some passive sensor. Passive sensor means no need power supply. Okay, for example, things like piezoelectric. Any of you use thermocouple in your workplace? Thermocouple sensor. It's basically you heat up the thing, you output some voltage. So that one is passive. You don't need to put external power supply. Okay, so that's passive. So try to know the difference between these two. Passive means no need external power supply to work. It works already. Okay, when you do that, when you use it straight, you can use it. Active means you need external power for the sensor to operate. Okay, so moving on. Now these are some of the sales pictures trying to show you different types of sensor. Okay, so as you can see, there are many types of switches. Okay, non-contact. Okay, you have those clamp. Any of you doing in Singapore doing power one? Any of you in the power industry? Some of you working in the power? Yes, clamp meter. You can clamp, you want to measure the current, right? You don't go and break the wire, right? You use a clamp, CT clamp. Okay, you can clamp and so on. There are different types. Okay, now there are many different sensors in the course, but in my course here, right, the important one that I will be looking at will be things like temperature sensor. Okay, because it's impossible to cover all the sensor, because I think you probably have to go university. A lot of things you can cover, okay? But for our course, okay, my focus is on temperature sensor. Okay, that's easily one exam question. Okay, in your exam. Okay. Now this one I think just to take note of it, this one just take note. This one performance characteristic there. Basically what they have is to us, right, if you think about it, a sensor, you can regard it as like a black box. I put a black box here. That means what I mean by this. Now, you see this black box, right? You can take it like it's a sensor. Now why I say that? Now the I stands for input, O stands for output. Now let me give you an example. Let's say if this is a temperature sensor, right? I tell you it's linear. What is linear? Do you know what does linear mean? Yeah, linear means it's a straight line, right? Okay, very good. Let me let's show you here. Okay, so if you have a linear sensor, for example, okay, so if I say that this is temperature, maybe voltage, okay, volts. So if it's a linear sensor, it's very simple, straight line. What does it mean? For every change in voltage, yeah, maybe just this is not real one. Just put some numbers to kind of show you. Okay, so it may not be actually true. Okay, 50, very simply. This is in degrees Celsius. Okay, so for example, something like this. Okay, linear system. Why I say linear? Very simple. Because okay, by default, you can actually know that. Let's say, for example, this is not to scale. And then tell you what. This graph is not to scale, I just sketching it. Okay, that means that for every sensor output, okay, it could be the temperature or some ways. Okay, output and input, you clearly know. Okay, you clearly know that. Let's say if the voltage is 1 volt, the output is 50 degrees Celsius. If it's 2 volt, it's 100. Okay, that's called linear. Okay, now linear things are very, very easy to work with, right? Very linear, I would know this is called the characteristics. Okay, if you know that it's linear, it's very simple to work. Okay, so so this is what I mean. You know the input, okay, you know the output. Okay, for every input that I give you, you know the output, because the manufacturer who manufacture the thing must give you the characteristic of the sensor, because otherwise I cannot use it. Alright, I must look at the data sheet, right, or the specs, right, of the sensor that I'm using. Okay, so linear stuff, very simple. Now these are some possible questions in theory. Just dim down the lights a bit. Okay, now these are some possible questions, but the marks will not be so much. Okay, I would say easily like 4 marks, 5 marks kind of short question. Okay, whereby they tell you to define some definition. So maybe it's good to just put a tick. Okay. Tick a bit, at least you can score some marks. We tend to ask you 1 or 2 of these questions, but I'll explain to you later on along the line. You know what's range, don't you? What is the minimum maximum range? Okay, so it's the maximum minimum value that can be measured. That's called the range, right? Okay, resolution. Okay, we will explain to you later. Smallest detectable change that you can measure. Okay, so the resolution is the smallest change that you can measure. Now error, okay, there are 2 main types of error: random error, systematic error. We will explain later. Okay, and then there's this thing called accuracy and precision. I'll show you later what we mean. Okay, what I mean by that. And then of course linearity is very simple. Sensitivity as well. So these are some things that we want to take note of, maybe for your theory part. Okay, short question. Okay. Now, let's say, for example, I give you a work example here. Can you have the notes, right? Is it the same one? Okay, let's say if I tell you, hey, I have a temperature sensor. Okay, So it's between 100 ohms to 180 ohms, but it changes. So you see it's linear, I think. So if I were to like sketch it over here, okay, so how would I put it here if I were to sketch a straight line? What is it? What versus what? Do you know? If I were to just check with you, do you all know? Right? If you look at this question, right? This example, right? What is this axis here? This one is what? Vertical axis. What is the vertical axis? If you look at this question here, look at this equation. Angle. What is this? You all know y equals to this familiar? Okay. Okay. Now, if I give you this, right? So what? Tell me what is the y-axis? This axis is the vertical axis will be the y, right?
Y.
So this y, this is x, right? Agree? Then what is the c? On your c, what is the c? C will be what? The intercept. If I cut a line like this, okay, and the c is this. The intercept on the y-axis. Okay, what is the m? What is m? Anybody? Slope. The slope, very good. Slope is the m, is the gradient, right? Okay, so that means it's the change in y, right? This one. Let's say if I call this y2 minus y1, right? Okay, this one is x2 minus x1. Right now, so m is your gradient. Okay, y2 minus y1, right? Over x2 minus x1. You follow? Right? This is the equation of a straight line. Very simple. We learned this when we were in secondary school. Right? This one, straight line of the equation. This is the intercept C. Is this kind of familiar to some of you? Straight line equation. Y here, x here. This is the gradient, which is sometimes called the slope. Okay, or the gradient, right? Means the same thing. Okay? Now this is C. Now, same thing if I were to use this over here, is the same thing. The one that you see in your notes, right? What's the slide? What's the page? Is there a page number there? No page. Never mind. Okay, never mind. No, it's just a work example. So in the same way, this is the same thing. Okay, now why do I say that? Now tell me what you think is the R. R is the resistance, right? T is the temperature. M is the slope. R0 is the y-intercept. Okay, so if I were to rewrite this thing, okay, let me use another color pen. Okay. Here will be R, right?
Yes.
Okay, it's exactly the same. I'll put a bracket here. Okay, now what is this? T, temperature. Okay, for example, this is T. Now what is this? C? Is the R0. It's the intercept. Okay, and then of course M is the same. M is the slope. Do you follow? You all see the relationship? Okay, let's calculate this one. Okay, in which R equals to M T plus R0. Yeah, I'm not teaching you all maths, don't worry. This is not really maths. I mean, the course is about sensors, but I need to explain to you this because somehow we need to use a little bit. But it's very simple and very, very simple. Okay, very, very simple stuff. Okay, so if you look at this word example, you can see that over here, right, they ask you to write down, for example, over here, right, they give you some values, and that means they say that it's between 100 ohms to 180, right? Okay, let's say over here, 100 to 180, okay, they want you to write down this equation here, in other words, okay, write down the equation. Okay, so basically you just substitute the value, right? Let's say if you know this equation, okay, I know that at 100 ohms is 20 degrees. If it's 180 is 120 degrees, right? Linear, very simple. So you can see over here. Let's draw you back to here. Now what we do is that we know the equation is this formula, right? So if I tell you it's if it's 100 ohm, it is at 20 degrees. Right, corresponds to 20 degrees Celsius. If it's 180, then it corresponds to 120. So you can actually put it in, work it out, okay, find out what is the slope, right? Then you can actually end up with something like this equation. But if you know this equation, is very useful, no? Because for every new temperature I give you, you know what is the resistance. Okay, so that's the whole idea. So this is just an example. This is an example. Just trying to show you that this is a linear equation. Right? Any questions? Okay, quite straightforward. Yeah, quite straightforward. Okay, so then another example here. Another word example. Slowly, get to the handle of this thing. Okay, so now what it says here in this example, right? It says that you have a sensor. Okay, it gives you this thing called the transfer function. Now, transfer function actually is nothing other than it's a gradient, it's a slope. Okay, transfer function means it's the slope. Okay, it's a slope. Okay, and it says that the slope is 5 millivolt per degree Celsius. Alright? So it asks you to find what is the voltage. So you can see that now always what I do, right, very simple. You look at this, right? Okay, now you can actually notice that what I did was, they ask you what is the voltage at the temperature of 0.2 degrees Celsius. Now what you do really simple is to look at the units. Now I take 5 millivolt per degree C, right, I times 0.2 degrees Celsius. I want to find the voltage, right? I want to find the voltage. So I take this value times this value because I can cancel away the units. Do you see now? If I cancel this degree Celsius, I cancel this degree Celsius, I left only the millivolt here, right? Then you see? So it's quite simple in a way. Okay, but what you're trying to do here, you must remember when you do this kind of thing, right? This kind of question, you look at things like the units. The unit tell us a lot of things. Okay, so in this case, the answer for this one is 1 millivolt. Okay, you understand? So it could be an example. This is just an example. Okay, take a look at this one. Now another example for you. Okay, so you read the question. It says that this particular transducer, okay, or sensor, okay, has this transfer function. Basically, is giving you the slope. So this is 22.4 millivolt per degree Celsius. Okay. Now, so for some temperature measurement, if the measured temperature is 412 millivolts, okay, what is the temperature? Yes, very simple. Okay. Now, if I take 412 millivolt, I divide it by this transfer function or the slope, this gradient, you can see that I always cancel the units. You see, if I take 412 millivolt divide by this, right, the millivolt and millivolt will cancel away, right? So I end up with only the units of degrees Celsius. Okay, so that is the answer. For example, okay, so maybe just take your time to understand this. I don't expect you to understand straight away. Slowly, okay? Go slow. Okay. So I erase this one. Okay. Anyway, the video will be capturing this. Okay. Okay, so now let's move on to this thing called what is accuracy and precision. This one should be a little bit easy to understand. Let me explain to you. Precision, right? Have you all come across these two words? Okay, some of you may. Now, if I were to show you a bullseye chart, then you will understand what I mean. You all seen this before? It's called a bullseye chart. Huh? Bullseye. Okay, you all play darts. Last time army days we play darts at the NCO club. Throw darts, kena arrow, right? can call it right, E0. Okay, let me explain to you. Okay, these are a lot of words here. Okay, I'll explain to you simply. Okay, let me tell you what. This one, I'll show you this one. In sensor measurement system, right, we always talk about precision and accuracy. Okay, look at this. Now, tell me, maybe you guess first before I tell you the answer. Or maybe in fact you don't have the answer. Now, this one is a bobo shooter, right? You want a bobo shooter? You army, you shoot, shoot everywhere. You shoot everywhere. You're supposed to shoot here, but shoot everywhere. So, is this precise? Is it accurate? No, this one lousy, bobo shooter. Okay, so this one is no, right? Very bad. How about this one? Tell me. Do you think this one precise or not?
Yes.
Precise. Okay. But later, see you say yes, later I'll ask you why. Okay. But is it accurate?
No.
Okay, very good. Your answer is correct. Answer is correct. But later I ask you why. This one?
Yes.
Precise and accurate. Okay, so what is precision? What is precise mean? You all say yes. You all give me the correct answer. Okay, but I want to hear you out. What do you mean by precise? Precision. You know, I don't know lah. Many of you go army, you zero your rifle, right?
Yes.
Why you need to do zeroing?
To bring the.
Okay, I see. Right. You all are saying something very sensible. Okay, I can see what you are saying. Why must do zeroing? Because if you don't zero, you can be very precise.
Yeah.
So what is precise?
Just as long as accurate.
Huh? What is precise? I think you all got an idea. Precise means what, when you shoot, let's say for example, I use shooting as an example, it's easy to understand, something like this, right? When you shoot, right, you keep shooting at the same spot, but that doesn't mean you are accurate.
Yeah.
Use error. You understand?
Yeah.
This one is accurate. Bullseye, you shoot at the target, this is accurate, damn accurate, right? Agree? This is precise, yes, but it's not accurate.
Yeah.
Precise means you can constantly hit at the same spot or around it. You see? Okay? This is both precise and accurate because it shoots at the correct target.
Yeah.
But it's very consistent. Okay, the word is consistent. You see the point? So there's a difference between accuracy and precision. Precision, you can be precise, yes, but not necessarily correct.
No, not good.
Yeah, but precision is a good thing, right?
Yeah.
Right, when we take measurement, we want to take it quite precisely, right? That means, for example, if I give you a digital multimeter or some instrument, I ask you to measure some voltage. Now, every time I take this meter, I go and measure, right? I always measure 240. Then I measure again, another 240. Another day, 2 days later, I bring this meter, I go and measure, still 240. Is it good? It's precise, right? It's precise, okay? Maybe it's also very accurate because, okay? So do you see what I mean? Do you understand what I mean? So precision means it's good because I want it to be repeated. Okay, the repeatability is very important. Oh, do you understand? So you understand the difference between precision and accuracy? Accuracy means of course good spot on, bullseye. Oh, okay. So maybe okay. So this one may be a theory question. Okay, if I ask you what is precision, okay, this is the okay, maybe just quickly show you this one first. So I think you know this one bobo shooter, shoot everywhere. Precision low, L means low.
Yeah.
This one accuracy low. This one precision high, but accuracy low, never hit the bullseye. This one both high precision, high accuracy. Oh, can? Can, very concept, very clear. So another thing to show you. Okay, can. Okay, any questions so far? Hey, you all don't want to take break now. We finish early and go off. Don't want to have break by the time we finish already. Okay, so we bulldoze through while you finish early I mean as in on time
We need to chapter.
No not the whole chapter. Then you stay here overnight.
Means what time?
How does Mr. Chan do it? Normally one time you all go 15, okay, so we try to along the line. Unless you all want me to do more, of course, your request. You all call the shots, you all call the shots. Okay, now let me give an example here, okay? Yeah, anyway, it's recorded, you all can kind of listen it. But of course, I don't encourage you all to miss class, right? I need the videos to help you, but try to come to class. Okay. So now let's take a look at this example here. Okay, now remember every sensor that you take from the shelf, you buy off the shelf or anything. Now there's always some level of inaccuracy. Okay, nothing is perfect right? Everything has some inaccuracy. Now let's say, for example, I give you an example here. Okay, now FS means full. Let me see how FS is full scale. Okay, FS is a term, right? Full scale. I think Mr. Chan also mentioned before. What's FS? FS is full scale. It means the maximum, in other words, okay, full scale, or what is the max value? Okay, FS means full scale. Now, what it does, we have a question here. Okay, it says that there are two different sensors, and you have a sensor A or transducer A and a transducer B. Okay, so you are asked to compare. These two, I give you these two transducer, okay, you say pressure transducer, right? Now let's see how good they are. How do we compare? Now, okay, it says that this, from here, you have the example, right? Okay. So it says that there is this inaccuracy of plus minus 1%, 1% error, okay, of the full scale. Now, what is the transducer A? What is the range? 0 to 10, right? 0 to 10 bar, okay, but that means the full scale range is 10 bar, right? The maximum, that's why I say it's maximum. So for A, the pressure that you can go is 10 bars, right? But you also have this accuracy plus minus 1%. Now the other one is a 5 bar transducer. Okay, now which one is better? I will ask you. But you cannot just say, oh, mini money, mini more, this one better. No, we have to work out a lot in scientifically and explain why is it better. Cannot just say, which one better?
The smaller range.
Okay. So some of you say the smaller range, but how? Let's try and figure out. Okay, now if I very simply what you do, right? You take the 1%, right, error, right? Because the manufacturer give you the specs. Okay. So what you do is that you take 1% of 10 bars. Right. So you all have the solution. Is there an answer there? Answer there, right? So what is 1% of the 10 bars? 1%. 0.1. Is it correct?
Yeah.
I'm sure you all know to do 1% of this one. So what about 1% of 5?
0.05.
0.05, right? Which means what? This one got smaller error or this one got smaller error? This one, right?
Yeah.
Right. But okay, but don't forget, okay, of course this one we say this one is better because it is smaller error, right? Compared to this one. But again, when you do a selection of the which one to use, it depends on your requirement. Okay, why? Because this has a range, right?
Yeah.
Okay, this one has got a range.
10.
Okay, 10 bars.
Yeah.
Okay, so it depends on your application. I can't tell you which one you will use, right?
Yes.
Because I need to know what is the measurement I'm measuring. Maybe I'm measuring the oil tank. I don't know, depends on your application, right? So it depends on what is your maximum and the range that you are looking for. Okay, but of course, if I can, I would want to have a smaller error, right? Of course, I want to go for this one, right? But if my measurement need to measure between 7 to 8 bars, what do? You cannot use this, right? Can you? Yeah. Cannot. Cannot because it's under range.
Yeah.
Right? You have to no choice forced to use this, but at the expense, I have to compromise, right? No choice. I have to compromise with the to bear the slightly higher error, so-called inaccuracy, no choice, right? Because I want to measure 7 to 8 bars. I cannot use this because I'm not enough, the range is not enough. So what you can see from here is that the bigger the range, what happens? The error higher or lower? Higher error, no choice. This is compromise. That's life. You have to compromise it. Okay, just that if you want a bigger car, then you have to pay more COE. Now very high. So I heard they say they did last 2 days. Still crazy. Now 100,000. My colleague just bought one Mazda 3. 1.5. 105,000. Mazda. The car. Together lah, bao ka liao all together. I think it's a 1.5 liter one, 1,005. So you can see no choice right? You want big, you pay more. This one, you want bigger range and more problem, more inaccuracy, no choice. Okay, trade off, trade off. You want smaller range, smaller range, smaller error. Okay, I think this is quite clear. Okay, smaller error, which one has a smaller error? Of course, is B. You all see the idea?
Yes.
Okay, good. Okay, you can see over here. So, okay, let's move on. Let's move on a little bit more. Okay, now we talk about conversion. This one maybe just for info. This one, info one, I'll tell you. Okay, this one can, if you can cross out, no problem. This one cross out. I would, along the way, that's why you all come for lecture. Okay, those things that we find that over time, I'm also trying to help you guys. I mean, you all cannot study everything for exam, you all will die also. No way. So, correct. No, I will, that's why I say I will try to help you. I will scope down the thing for you. Right. But syllabus wise, I got no choice. I have to cover. But I will tell you this one, okay. This one maybe, okay, this one important. This one, maybe, you know what I mean? Okay, so do come to class and then you can hear all these little hints. Okay, this one you can cross out. This one, cross out. So you basically can take a pen very safely, just cross out. Okay, this one cross out. Now, slowly. This one is for info. You can put.
For info also cross out.
For your info. For you to know. Okay, like okay, there are different sensors, right? They are on the, when you have different sensors, you can have different types of signal conditioning. Okay, before you go to the data acquisition. Okay. So for example, now some of the, let's say, signal conditioning stuff, maybe you like have things like filters, right? I can have amplifiers, right? I can have other things, okay? And so on. Just for your info, okay? Okay, bridge circuit. Last time, I think about 3 semesters ago, we tested one question in the exam. No, in fact, last semester, sorry, let me try and recall. Last sem we had a question on this. So normally, generally speaking, okay, what we do is that the system here, the exam system here, we tend not to repeat questions for 2 semesters. Get the idea? Yes. For 2 semesters, we will not repeat the same question. Oh, you understand? Okay. Yeah. Okay, so basically, for this one, right? Okay, I will explain this one in a bit later on. Not today, not today's lecture. But there's this thing called the bridge circuit. Okay, you all may have heard before. It's something also sometimes called Wheatstone bridge. Wheatstone bridge. I don't know. Don't ask me why they call Wheatstone. Somebody, probably some smart guy came up with this thing. Okay, it's called Wheatstone bridge. I also don't know why they call it Wheatstone bridge. Yeah. They call it the Wheatstone bridge. What it does is that they put 4 resistors, right? When these 4 resistors are balanced, balanced means they have the same value. The output when you measure is 0. Okay? So especially useful when you measure like things like strain gauge. You measure force, right? Like like weighing machine. Okay, that kind of concept. They also use things like strain gauge to measure the force or your weight. Okay, so when the thing is balanced, the output is 0. Okay, so this one could be a sensor that I put in. Okay, so they use a concept or technique called Wheatstone bridge. Okay, so we'll explain later. Okay, this one you can cross out. Cross, help you, it help. This one cross out.
But topic 4 we learn
Huh? No, but as far Mr. Chan one I won't have any say. What he said is he said. But what I said I have control, right? Obviously. So I will tell you what safely this one means you can safely take it out. But if you need it for Mr. Chan to explain his part, then of course you need it. The one I don't say, I cannot tell him what to do. No, we shared. He said 2, I said 2.
Okay.
But I can safely tell you what I will cover, what is not. Okay, I think it's fair, right?
But you cross, then you never cross.
But this is for my part. His part I don't know. The one let him. Okay, but for my part I cross out. I don't need this one.
Okay.
Cross. Okay. This one you cross. This one I'm starting to remove this section on signal to noise ratio. So we cross out. Is it cross in your notes? No, right?
No.
So cross it out. Cross it out.
So topic 5 to 7 is 7.
Yes, correct. I will only cover topic 5 to 7.
or you break the paper.
No, we got two. In fact, 3 levels. The question paper have to go through 3 levels. You can imagine how xiong. We set paper very xiong. We set already, right? We have to go to internal moderator, 1 level. So one clear, right? Then go to senior moderator. Until they clear, then they go to academic quality. AQ, we have an AQ team to check, make sure the quality is there. So you can see 3 level, very jialat, no? Module leader, we die on. Basically, the question, we go 1 level, the fellow ham us. This one change, this one change, then we come back, we change, then we go to senior. Then senior also not happy, change. We come back to us, we change, then we go up again, then he's happy, then go up to another level. So we die. Yeah, very jialat, 3 levels. At least take 2 months to get the paper out. 2 months. Okay?
So the paper you get LE.
Not yet, not yet. Now at internal moderator. Okay, this one cross.
Okay.
The important part is coming. Of course, the beginning part we are changing already. We are changing some stuff. This one cross also. Please cross up. This one basically this whole small section is taken out. Okay, under the noise part. So it's cross. This one cross. Okay, and then okay, cross until here. Can you all do that? Cross out. Okay. Cross out. Just safely cross it out. Yeah. Okay. See that.